All right, so we're going to do a quick overview of Newton's laws. This should be review from sixth grade, but I wanted to take a minute and make sure that everybody is remembering all of these things. So Sir Isaac Newton is why we call it Newton's laws. And he actually started developing these when he left university in 1665 because there was a plague. Sound familiar? So he ended up social distancing himself on his family's farm for 2 years. Folks, there was no social media then, no internet. And he just focused on his work. He came up with the big ideas of motion, gravity, calculus, optics. So he developed all this stuff while he was thinking and working on his family's farm. And there's that story about him getting hit in the head with an apple. Most people don't think that actually happened, but it's a good story, so we keep telling it. So I wanted to go over this and make sure that you all know Newton's laws. So while you are watching this, what you need to do is have the notes pages open in Schoology, and in Kami, you can follow along with each slide. It's guided notes, so you'll see spaces for the important words that I have pulled out from this presentation. All right, so in a nutshell, 3 main laws. The first law is that an object at rest will stay at rest unless acted upon by an outside force. We've been talking about this, right? And there are always forces around, and just because something isn't moving doesn't mean there's no force acting on it. The opposite is also true. A force will keep moving unless acted on by an outside force. This law is also known as the law of inertia, and we'll talk more about that word in a moment. The second law is, Newton's second law is basically describing force. Force equals the amount of mass that an object has times its acceleration. So you can think here about the activities we did where we had the block and we put different weights on it and we slid it across the different surfaces. So you can think about that, or just kind of what you know about life, right? It takes a lot more force to push a larger object than a smaller object. Acceleration, for our purposes, we're going to only learn the acceleration due to Earth's gravity. So that's kind of the only number that I will introduce to you next week for acceleration. And then the third law is that for every action, there is an equal and opposite reaction. All right, so those are Newton's 3 laws of motion. So a little bit more about the first law. An object in motion tends to stay in motion with the same speed and direction unless acted on by an unbalanced force. So remember, at the very beginning, we talked about balanced versus unbalanced forces. That just describes how an object reacts. So if you've got unbalanced forces acting on an object, the object will move in a different direction. But balanced forces will keep something moving constantly, or will constantly keep it at rest. So kicking a soccer ball, a satellite orbiting the Earth, right? So those are examples here of Newton's first law. Inertia is also part of Newton's first law. And it's a fancy word that describes why an object doesn't move. And if you think about a bigger object, it's harder to get it to start moving. It has more resistance to changing its motion. And inertia is due to the amount of mass in an object. The more mass, the more inertia. So if you're in a car and you're a passenger in the car, or you're the driver, and all of a sudden you stop really quickly, you will keep moving forward. That's why seatbelts were invented, because if the seatbelt doesn't hold you back, you're going to keep moving forward, and then you smash your face on the steering wheel or the windshield or whatever, right? So inertia is the resistance of an object to a change in motion. And again, if you have a bigger object, it's harder to stop it. There's all sorts of stories about collisions, especially things between really large boats. There was a bunch of accidents recently where there were really large sort of like aircraft carriers, and they ended up colliding with smaller boats because literally they couldn't stop the boat. It's just too much inertia to slow the boat down. There's just no way they could get out of the way in time. Newton's second law is basically describing how we know what a force is. So it's an equation, but it talks about the mass times the acceleration of something. And acceleration is just the rate at which an object changes its speed or direction. So you can be talking about acceleration in terms of something speeding up. You can be talking about acceleration in terms of something slowing down, or in terms of something changing its direction. So an example, downhill on a roller coaster, uphill on a roller coaster, turning a corner. These are all examples of acceleration. It doesn't always have to mean something that's speeding up. We can find acceleration, we can find mass, we can find force, and there are lots of equations that help us find each of those pieces if we don't know one of them. But acceleration is produced when a force acts on a mass. So again, the more mass, the greater the amount of force needed to accelerate that object. And again, we talked about this in class, right? With the little toy cars versus the giant cars in the parking lot. It's harder to get that big car started moving, but then it's going to have more acceleration once it is moving. So it's going to then be harder to slow down again. Newton's third law is action-reaction. And I know you all have heard this before. For every action, there is an equal and opposite reaction. So a rocket taking off, right? There's an action that pushes that rocket up, the thrust, right? The force that is pushing the rocket up. And there's lots of other action-reaction forces that you may not even have thought about. Earthquakes, volcanoes, rift valleys. Those are all created by unbalanced forces because of Newton's third law. All of a sudden, right, there's an earthquake, rips the earth apart. That's action-reaction. So Newton's third law. And that, my friends, is your very quick overview of Newton's laws. Hopefully that was helpful, and you can use that for your notes.